Hello everyone. In the today's lecture, we will discuss about the common source amplifier with source resistance. That means this is the common source amplifier again because the source is common for both input and output, and the output is taken at the drain terminal. Okay, and we have only two capacitance: the input capacitance and the output capacitance, and there is no bypass capacitance for this circuit. Okay, since there is no bypass capacitance across any capacitance across the resistance Rs, this is called as common source amplifier with the source resistance, right? So now to do the small signal analysis of the same, we write the small signal model first. So this is the small signal model for the transistor alone. So now the modified circuit of this following the procedure what we do, that is all the DC supply should be connected to ground and all the capacitors should be shorted, and any capacitor or any resistance associated with the capacitance in parallel, that will be neglected. Okay, so this is the modified circuit shorting the capacitor, okay, R1, R2, RD and RS, okay, and the DC supply is connected to ground. So this is the modified circuit for the given circuit. Fine, this is Vin. So now to write the small signal model, so we have these components to add along with the MOSFET model what we have added here. So now we have RS, R1 and R2 which is connected from gate terminal to ground. Here also it is grounded. So from gate terminal to ground you have R1 and R2. So this is my V in from gate to ground or the reference, okay, and this is my input current I in. So this R1 and R2. So these are parallel, and the resistance Rs is from source terminal to ground. So here we have resistance Rs from source terminal to ground, and Rd is from drain terminal to ground. So from drain terminal to ground, okay, this is RD. Fine, and we are taking the output across drain terminal from drain to reference, that is ground. This is my V out. So my V out is from drain to reference, right? So this is my small signal model for the circuit, right? So now to do the analysis, we have input impedance Zin corresponding to input voltage and input current V in and I in. So input impedance is the impedance seen with respect to input terminal, input voltage and input current, right? And when we see from here, that is R1 and R2 are parallel again here, like in the previous case what we discussed for the simple common source amplifier with bypass capacitance. The output impedance is R1 parallel with R2. So this is VGS from gate to source. This is the source terminal, and from here to here it is RS, whereas from here to here it is an open circuit, infinite plus RS. These two are in series. So R1 parallel with R2 parallel with infinite, it will be approximately equal to R1 parallel with R2. This is the final output impedance of the given circuit, right? So similarly, to find the gain, so here we have the current flowing in this direction. So this is the direction of the output current ID, which is opposite to that of I0. Okay, so my output voltage V0 is equal to ID I0 into RD. It is the voltage across the resistance RD. Okay, and here I0 is nothing but minus ID into RD, whereas minus ID is nothing but GM into VGS. ID is GM into VGS into RD, right? So this is my output voltage. Okay, we'll consider this as equation 1. So consider the input side. So here input side we have voltage from gate terminal to ground. Okay, so from input side you can say that So this input is nothing from gate to V in is nothing from gate VGS plus VS. From here to here it is VGS, and from here to here it is VS. So that is the voltage which is nothing but V in voltage distributed across these two branch VGS and resistance RS, right? So now here anyhow V in is what we are going to calculate here. VS is nothing but the voltage across RS, and the current flowing through the RS is again ID. Okay, so VS, this is VGS plus VS is ID into RS. VGS plus ID is nothing but GM into VGS again. GM into VGS into RS. So V in is VGS into 1 plus GM into RS, right? Consider this as equation 2. So my gain, okay, which is voltage gain, output voltage by input voltage, by equation 1 divided by equation 2, I get minus GM into VGS into RD divided by VGS into 1 plus GM into RD. Okay, so VGS cancels, and my voltage gain is nothing but minus GM into RD divided by 1 plus GM into RD, GM into RS. This is RS here, sorry. Okay, GM into RS. So this is the expression of gain, right? So in the earlier case we got the value of gain as minus GM into RD, whereas now here in this case it has reduced by the factor 1 plus GM into RS, and this happens to be because of the presence of resistance RS. Hence the gain reduces in the common source amplifier with source resistance. Okay, considering the output impedance which is Z0, which is nothing but the impedance seen with respect to output voltage from here to here. So when we are considering the output impedance, the Thevenin's equivalent impedance between these two terminal, during this time what we do, we short all the voltage source, and here we short the input voltage. When we short the input voltage, R1 and R2 will get neglected because of it becoming the 0, and we need to know that VGS also will be equal to 0. And if we consider this equation, consider the same V in second equation. By equation 2 we have V in is equal to VGS into 1 plus GM into RS. Okay, so here what happens, V in is 0 is equal to VGS into 1 plus GM into RS. So we are making the input voltage to be short to find the output impedance. So when this is 0, obviously the 1 plus GM RS cannot be equal to 0. Okay, so this term will not be equal to 0, hence your VGS will be equal to 0. Okay, so hence VGS is equal to 0. Hence in this equation what happens, V in is equal to VS. Okay, V in is equal to VS. Okay, I mean to say not V in is equal to VS. When VGS is equal to 0, this current will become open circuit, completely open circuit. Okay, when this becomes 0, this R1 is also neglected, R2 is also neglected, and this is also open circuit. So only you left with resistance RD. So the impedance what you see with respect to the output terminal, this drain and reference is nothing but the impedance RD. Okay, so the output current is I0. So Z0 is nothing but RD itself. This is the output impedance. Okay, so now we will just solve a problem on the same, considering the common source amplifier with bypass capacitance. Fine. So now consider the circuit common source amplifier. This is RD, RS. So we will have a bypass capacitance. With bypass capacitance we will discuss. So this is input capacitance, this is output capacitance, and this is VDD. We will take this as plus 30 volt, R1, R2, 40 mega, and this as 10 mega ohm. This is V in. Okay, RS we will take it as 1.2k. okay, and we will consider the threshold voltage of the device to be as 3 volt, and the device transconductance Kn is 0.4 milliamps per volt square. Okay, we will consider this as the given circuit. We have to do the AC analysis for this, and the AC analysis means first we have to do the DC analysis to find out what is the current. Okay, the current and also the transconductance, which is the DC parameter. Okay, so to do the DC analysis, we have, so the resistance R1, R2, RD and RS, all the capacitance are made open circuit. Okay, when we are doing the DC analysis. Fine. So now here first we will find out what is input voltage. V in is nothing but the voltage from gate to here, that is reference. So my VG is nothing but the voltage across 10 mega ohm resistance. Vg is equal to 10 mega into the current flowing through this resistance R2, 10 mega ohm, which is given by 30 volts divided by 40 mega plus 10 mega. Okay, so now the gate voltage is nothing but the voltage across R2. So this is the resistance and this is the current which is flowing through the resistance R2. Okay, so on solving this, you will get Vg as around 6 volt. You will get Vg as 6 volt, right? So now to find out VGS, we'll consider it as Vg minus Vs. Vs is nothing but the voltage across the resistance Rs. See, this capacitance will get here during the DC analysis, the capacitor are made open circuit. Okay, when we are doing DC analysis, capacitance are open circuit. Okay, and when we do the AC analysis, then the capacitor are short circuit. Okay, Vg minus Vs. So Vs is nothing but the voltage across resistance Rs. So this will be Vg minus Id into Rs. VGS. Okay, so this Vg is anyhow 6 minus Id into Rs. This is VGS. Now, since this is an amplifier, we assume that the MOSFET is in saturation region. Okay, so now for this we have the saturation current equation, which is Id is equal to half Kn VGS minus VT whole square. Okay, so this is the equation of saturation current equation. We have assumed that transistor is in saturation region and this is the corresponding saturation current equation. So now substituting this Kn value and VGS as this equation 1, okay, on solving for this, Id is equal to 1 by 2, Kn is 0.4 milli 0.4 milli into VGS is 6 minus Id into Rs minus Vt is 3 volt. Vt is 3 volts, which is given here. So whole square. So Id is equal to 0.2 milli into 3 minus 6 minus 3 Id into Rs whole square. Okay, so now on solving for this, you will get the equation which is 1.44 into 10 power 6 Id square minus 9700 Id plus 9 is equal to 0. Okay, so solving this quadratic equation, we will get the value of Id as 5.62 milliamps and another value as 1.11 milliamps. So among these two, if you take this as the current, the device will not be in the saturation region, so you cannot take this. So if you take this 1.1, your VGS will be positive and hence the device will be in saturation region. So substituting this here, VGS is equal to 6 minus 1.1 milli into RS is 1.2 kilo. So you get VGS as 4.66 volts. Okay, so this is my VGS. So once you get VGS, you can find out GM. GM is, you can find out GM. GM is nothing but 2 Kn into VGS minus VT. So it is 2 into 0.4 milli. VGS is 4.66 minus 3. So on solving this, you will get GM as 1.33 millisiemens. This is the GM. So once you get GM and VGS, you can do the AC analysis. Now AC analysis. Now when you do the AC analysis, capacitors are short when you are doing the AC analysis. So here we have the equation corresponding the input impedance, which is R1 parallel with R2, which is equal to 40 mega parallel with 10 mega. You will get Zin approximately 8 mega ohm. Zin, okay, and Z0 is nothing but RD, which is equal to how much? RD we have not taken, right? RD you take it as 3.3K. You will take it as 3.3K. That itself will be the output impedance. Okay, and the gain AV is nothing but minus GM into RS. You will get minus GM is minus 1.33 milli multiplied by RS is 1.2 kilo AV. So you will get AV as minus 4.3 or 4.4. This is the gain of the amplifier, right? So this is common source amplifier circuit for the discussion.